Good morning, everyone. I welcome you all to the course on chassis and body engineering. The subject code is MAUE5004. So today we will see the topic on the introduction to aerodynamics. So let us move to the first slide, which is on introduction to aerodynamics. So before moving on to the introduction to aerodynamics, so let us first see what are all the prerequisite or recapitulations for the subject. So first, the meaning of aerodynamics. Secondly, the meaning of Formula One car. Thirdly, the fundamentals of fluid mechanics, where we would have studied in our previous batches, the previous years, the concepts of lift and drag in the vehicular design, and also the history of aerodynamics in chronological order in order to improve the performance. So these were some of the prerequisites or recapitulations that we should have in order to bring this course forward. So after we have studied, gone through the prerequisites of this course, so let us now see what is the objectives of today's lecture. So the objective number one is to understand the meaning of aerodynamics and its scope in vehicle industry. The second objective of today's lecture is all about to understand the concept of downforce. The third objective of today's lecture is to understand the front wing effect on the aerodynamics of Formula One car, popularly known as F1 car. Fourth objective is to understand the principle of rear wheels, diffuser and barge boats. So you all will be able to understand the physical significance of the rear wheels, diffuser as well as the barge boats in the upcoming slides. And also, last but not the least objective is to understand, which is very important to understand, the few techniques as to how to reduce your vehicle's drag, or in other words, the air resistance. So we will see all these objectives being achieved as and when we move forward in our slides to come. Now coming to the introduction part, where I'll tell you the definition of an aerodynamic system. So what does aerodynamics means? So aerodynamics is the study of moving gases. So in our case we will take it as air over a body in motion, and how that airflow will affect the body's movement through the flow. So car aerodynamics makes the car more safer and make it more fuel efficient. It is used in most of the cars today, especially in race cars, because there is more need of aerodynamics in high-speed car. So as you have understood the meaning of aerodynamics, so let me take you to the evolution that has taken place over the period of time, that the physical significance of aerodynamics will come into picture once you see the next slide. So after studying the fundamental meaning of aerodynamics, so let me take you to the world where you will understand the transformation of vehicles in terms of aerodynamic study that has taken place over the period of time. So as you can see in the first picture, the image of a car, where you can see the transformation that has taken place in the design of the wing over the period of time. So likewise in the second picture also you can see a car, and in the fourth picture you can see how the aerodynamics study has come into picture, and what is the role of aerodynamics in creating the wing shape, in creating the aerodynamic structure of a car. So it will modify the car so that your performance of your car is going to increase. So when I speak about the history behind the aerodynamic of a car, I can say that aerodynamics has played a very important role in car racing since the late 1960s actually, when introduction of the first invented wings appeared in some formula cars. So after that time, over the period of time, improved wing systems taken place from the aeronautic technology made leaps forward, improving consistently lap times, increasing the cornering speeds and the vehicle stability as well. So with the introduction of the ground effect, a few years later on, the vehicles used a third element to produce the downforce, and hence resulted in improvement of the performance. Now we will see the importance and the physical significance of the downforce. So till now we have seen the introduction to the aerodynamics, the fundamental meaning of aerodynamics, and then we have seen the history or the development of the aerodynamics role in the development of the Formula One car. And we have also come across one important term in the history, that is the downforce. So this slide will focus purely on the downforce, the importance of downforce in the aerodynamics study. So the fundamental meaning of downforce is that it describes the downward pressure. It describes the downward pressure created by the aerodynamic characteristics of a car that will allow the car to travel faster through a corner by holding the car to the track or on the road surface. So I once again would like to describe it. So it says it is all about the downward pressure created by the aerodynamic characteristics of a car that will allow it to travel faster through a corner by holding the car to the track or on the road surface. However, it is also important to note that it also inverses the friction between the tires and the road surface. And what will happen then? Then it will decrease our maximum velocity. So that is, whenever the inversion, it will inverse the friction between the tire and the road surface, and in that case our maximum velocity is going to decrease. So it's a force, in other words I can say it's a force which will arise due to the airflow over and below the car, which act vertically downwards on the car. So I would like to tell more about the downforce. That is, downforce is the downwards lift force which is created by the aerodynamic characteristics of a vehicle. The purpose of downforce, we should understand the purpose of downforce. So the purpose of downforce is to allow our car to travel faster through a corner by increasing the vertical force on the tires. Then it will create more grip. So it is very important to note that the purpose of downforce is to allow the car to travel faster through a corner by increasing the vertical force on the tires. And what will happen because of that? It will create more grip. So again, going into the details on the what do you call the downforce, the same principle that allows an airplane to rise off the ground by creating lift from the wings will be used in reverse to apply the force that will press the race car against the surface of the track. So I once again would like to repeat the statement because it's a very important statement to note. The same principle that allows an airplane to rise off the ground by creating the lift from the wings will be used in reverse to apply the force that presses the race car against the surface of the track. So this effect will be called as aerodynamic grip. So as I told you in the downforce definition, that the purpose of the downforce is to allow the car to travel faster through the corner by increasing the vertical force on the tire, and what will happen because of that? It will increase the more grip. So this is known as aerodynamic grip, and it is very much different from the mechanical grip. So we shouldn't get confused between the aerodynamic grip and the mechanical grip. Both these terms are fundamentally different. Okay. So the mechanical grip, if we talk about the mechanical grip, it is a function of car's mass, car tire and suspension. So that is all about mechanical grip. It is a function of car mass, car tire and suspension. The creation of downforce by passive devices could be achieved only at the cost of increased aerodynamic drag. So I will tell you the fundamental meaning of aerodynamic drag in the very next slide, but meanwhile you can understand that the creation of this downforce by some of the passive devices could be achieved only at the cost of increased aerodynamic drag, or in other words friction. And the optimum setup is almost always a compromise between the two. You understood? So the aerodynamic setup of a car can vary considerably between the racetracks. So between the racetracks, your aerodynamic setup is going to vary very much or considerably. So it all depends upon on the length of the straights and the type of the corners that we have. So depending upon these two factors, that is the length of the straights and the type of the corners, the aerodynamic setup of a car will vary tremendously between the racetracks. So because it is a function of the flow of air over and under the car also, downforce will increase with the square of the car's speed, and it will require a certain minimum speed in order to produce a significant effect. So this is again one of the important thing to note. So I'm repeating once again, take a note. So since it is a function of flow of air over and under the car, so downforce, what happens is downforce will increase with the square of the car's speed, and it will require a certain minimum speed in order to produce a significant effect. So I hope this sentence is clear to all of you. See, some cars have had rather unstable aerodynamics, such that, so what do you mean by unstable aerodynamics? We call as a minor change in angle of attack, or the height of the vehicle is changing. So that can cause large change in the downforce. So that we call it as the unstable aerodynamics. Okay, so unstable aerodynamics means it is a minor change in the angle of attack as also the height of the vehicle, and that will have a very large impact in the downforce. So here we can easily see the application of aerodynamics in the Formula One car, which is popularly known as F1 racing cars. So aerodynamics is the single most important aspect of F1 car design. It not only defines the entire shape of the car, but also the position of all items within it. So by items, I mean to say the engine, the gearbox, the driver, etc., etc. So the positioning of all the items as well as the entire shape of the car, what governs the aerodynamics in Formula One car. So in the last slide, we saw how aerodynamics is important in a Formula One car, and this slide will tell you what is the role of the front wing effect on the aerodynamics of a Formula One or the F1 car. So the front wing, as you know, is very important because it is the first part of the car or the vehicle that will make contact with the moving air outside. So that's the first part that's going to contact with the air. So it is one of the element that is used for downforce because it is going to create a very high pressure area on top of the surface, and once the pressure area is large, automatically your downforce is going to be very large, as you can see in the images where that is presented just below the words. So after the aerodynamics of the F1 car, as I told you, there are many parts in which the aerodynamics design comes into the picture. So one of the important part in it is a diffuser. So what do you mean by diffuser? The diffuser, or as you can see in the diagram also below, so if you can clearly look at the photograph below, that it is the diagram that shows you the parts of the diffuser. So diffuser, in other words, it is called as the floor, which is specifically designed to ensure the smoothest exit for the air that is flowing under the car. So the diffuser is designed to ensure the smoothest exit for the air that is flowing under the car. So designers nowadays are coming up with a huge variety of complicated shapes, because it's a fact that the more quicker the air exits, the more downforce the car will generate, and once it generates a more downforce, you can easily understand that the car will be more faster. So the designers nowadays, or the technologists and the scientists, are coming up with innovative ideas or the complicated shapes of the diffuser, so that the air exit quicker. So when the air exits quicker, we know that the more the downforce will be produced by the car, and when that happens, the car will move faster. So that is the basic fundamental principle behind the Formula 1 cars or the F1 cars. So after the diffuser design that is taking place in the entire world, the innovative diffuser designs is going on in the researchers' mind, so that you can achieve the more speed Formula 1 cars. So another important part, which is the barge boats. So barge boats, as you can see in the diagram, you can also picturize. You can also picturize the barge boats in the diagram, that how the movement of airflow is taking place near that. So barge boats is also called as your turning vanes. What it does is it will smooth out and separate the air that has been disrupted by the front wheels. So that is, it just will smooth out and it will separate the air that has been disrupted by your front wheel of your car. So they separate the flow into two parts. So first part will be directed into the side ports to cool the engine, and the second part of the flow will be diverted outside in order to reduce the drag. So here comes the picture of drag, which will be the focus of my focus in my next slide. So once again, let me repeat the statement that the barge boats separate the flow into two important parts. One is directed directly into the side ports so that your engine cools, and the second one will be directed not directed, it is diverted outside so that your drag is going to reduce. So after we have gone through the previous slide, this slide is all about the fundamental definition of the drag force. So here you can see in the slide, on the left hand side of your graph, we are having the drag percentage and versus the different kinds of vehicles that we have over the period of time. And we can see that we have selected four different vehicles. One is the heavy truck. We have also picked up the light truck, the subsonic airplane, and the water surface vehicle. So here you can see that the pink region that is shaded over there is represents the friction drag, and the blue region represents the pressure drag. So before I explain this slide, let me take you to the world of drag forces. So first we should understand the fundamental meaning as to what the drag force is all about, and then we'll be able to differentiate the different types of drag. We'll be able to appreciate what a friction drag is all about, what pressure drag is all about, and things like that. So let me first take you to the world of the drag forces. So in physics, or in the fluid dynamics, or in fluid mechanics, so as in our previous academic background, or in our class 11th physics, or in our fluid mechanics subject in our BTech courses, we would have studied that the drag, that is sometimes called as the air resistance. So it's a type of friction. Or the fluid resistance. So the drag is sometimes known as the air resistance, or the type of friction, or the fluid resistance. So another type of friction or fluid friction. So whatever you call it as, drag is very important. So it is, in simple words, if I say, it is a force. It is simply a force acting opposite to the relative motion of any object moving with respect to a surrounding fluid. So I hope this definition is a crystal clear, that a drag, which is also known as the air resistance, or it's a type of friction, you can sense it that way. It's a force which will act opposite to the relative motion of any object moving with respect to a surrounding fluid. The fluid may be air, the fluid may be anything in that case. So this drag will exist. So a little bit more about the drag forces, since in order to understand the friction drag and the pressure drag, we need to know more about the drag. So drag definition is clear, I think. And now the drag can exist. So talking about the drag, so the drag can exist between the two fluid layers or surfaces, or I can say a fluid and a solid surface. So unlike other resistive forces such as the dry friction, which is nearly independent of velocity, so the drag forces will depend just on velocity. So I repeat, because the statement is to be noted, it is very important. And so you can I repeat once again that the drag forces is nothing but and the air resistance or the fluid resistance. It's another kind of friction which is a force which is acting opposite to the relative motion of any object, so moving with respect to a surrounding fluid. So it will exist between two fluid layers or one fluid and a solid surface also. So unlike other resistive forces, we have some resistive forces like dry friction, so which is independent of velocity, but the drag forces will purely depend upon velocity. Okay. So drag force is proportional to the velocity for a laminar flow. I hope the laminar flow and turbulent flow is something that you would have done in your subsequent years in your bachelor's degree. The laminar flow is a streamline flow, and turbulent flow where you have the turbulence that is being created due to the external forces like the eddies or anything. So drag force, I'm not going to detail into that, but let me tell you the drag force is proportional to the velocity for a laminar flow and the squared velocity for a turbulent flow. Okay. So in case of laminar flow, it is just directly proportional, but in case of turbulent flow, it is the square of the velocity on which your drag force depends upon. So even though the ultimate cause of a drag is the viscous friction, the turbulent drag is independent of viscosity. So drag force, what it does to the fluid is, it will always, remember this, it will always decrease your fluid velocity relative to the solid object in the fluid's path. So I repeat the statement again. So it is always going to decrease your fluid velocity relative to the solid object in the fluid's path. So okay. So let us simplify this drag force and understand this through an example. So examples of drag include the component of the net aerodynamic or hydrodynamic force, which is acting opposite to the direction of movement of a solid object, and by solid object I mean to say such as cars, aircraft, boat hulls, or acting in the same geographical direction of motion as the solid, as for the sails attached to a downwind sailboat, or in intermediate directions on a sail depending on the point of sail. So in the case of viscous drag of fluid in a pipe, I'm talking about the pipeline, the drag force on the immobile pipe will decrease the fluid velocity relative to the pipe. So in the physics of sports, the drag force is very much necessary to explain the performance of runners, particularly of sprinters also. So this was something on the examples. Now talking about the types of drag, we generally divide it into the three types. The number one is the parasitic drag, which consists of again two subdivisions, which is the form drag and the skin friction drag. The second category is the lift induced drag. And we also have the third category, which is wave drag. In other words, we call it as wave resistance or ship hydrodynamics, etc. So a little bit about all these three terms. The parasitic drag is mainly used in aerodynamics, since for lifting wings, drag is generally small compared to the lift. Lift induced drag is the only relevant when wings or a lifting body is present. Therefore, it is usually discussed either in aviation or in other words I can say in the design of semi-planing or planning hulls. And the wave drag will occur either when a solid object is moving through a gas at or near the speed of the sound, or when a solid object is moving along a fluid boundary, as in the surface waves. So drag, it always, remember this, it depends upon the properties of the fluid and also on the shape, size and speed of the object as well. So we express, mathematically we can express this equation, this drag force, by one of the famous equation, which is Fd will be equal to half multiplied by density multiplied by square of the velocity multiplied by area and multiplied by coefficient of drag. So it is half rho Av square into Cd, where Cd stands for coefficient of drag. So now coming to the frictional drag, and what do you mean by this pressure drag? So friction drag is very much important, for the attached flows. So what do you mean by attached flows? Attached flow means when there is no separation at all and it is related to the surface area exposed to the flow. You understood? So it is, friction drag is important for attached flow and it is related to the surface area exposed to the flow. Now what about pressure drag? Pressure drag is also important for separated flows. So frictional drag was for no separation flows, but pressure drag is for separated flows, but it is related to the cross-sectional area of the body, whereas frictional drag was related to the surface area which is exposed to the flow. I hope this difference is very much differentiated, the pressure drag and frictional drag. Now the pressure drag will arise. How it arises? It will arise due to the shape of the object, and it will also depend on the flow separation point, etc. So now you can see this slide that it is having 4 different vehicles, and we have compared the frictional drag contribution and pressure drag contribution for 4 different vehicles, and you can see that in the subsonic airplane, it is the drag is relatively 50-50, that is friction drag and pressure drag. But in the case of heavy truck, we all know the pressure drag will act more in percentage, somewhere around 90%. But in case of friction drag, it will be very less. So now we have to think about the more procedure as to how to reduce your drag or air resistance. So you can clearly see in the picture also that but before going into the picture, let me cover these 3 points which is written over here. So we have to make the shape of the car so that air flow together smoothly towards the end of the car. So this is one way to reduce your drag. The second way is to reduce the frontal area of the car by minimizing the grille, making sure that windscreen is as flat as possible. So this is the second step that has to be achieved so that you are able to reduce your air resistance. And the third, very basic, cover the wheels. So you can see in this diagram that how the structure has changed over the period of time by aerodynamically changing. You can see the wing shape, you can see the shape of the wheels, and you can see how aerodynamic study has taken place over the period of time. So overall, I can say that the use of aerodynamic devices will greatly increase the performance of a car. The trick is simple. A trick is to be able to generate just the right amount of downforce while keeping the drag to a minimum. So this picture is something which people usually simulate in the software, where we have shown the airflow patterns in a Formula 1 car. So you can see that the Formula 1 car is presented over here. So how the air flows when the Formula 1 car is racing on a track. So how the airflow pattern looks like. So this is just simply put up by me so that you can visualize how the airflow pattern looks like in a F1 car, but this has to be simulated in a software, which will be the focus of the subsequent lectures to come. So in summary, I can conclude that, see, automotive aerodynamics is the study of aerodynamics of the road vehicles. So our main goal was to reduce the drag and wind noise, minimize the noise emission, and prevent undesired lift forces and other causes of aerodynamic instability at high speeds. So air is also considered as a fluid in this case. So as we have come to the end of the lecture, so let me put forward few questions which you can practice whenever you have a time. So the first question I want you to think about is what is the effect of lift and drag forces on the aerodynamic stability of a body. So you need to think about few instances where the aerodynamic stability takes place, the situations where aerodynamic stability will come into picture, and then we have to analyze the effect of lift and drag forces. So that is question number one, which you have to practice. Second is list the importance of CD and mention the CDs of various engines. So CD, as I told you in the drag, when I was covering the drag, that is the coefficient of drag. So you have to list its importance, and you have to list the CDs of various engines. For example, for car how much it is, for aerofoil how much it is, for aeroplane how much it is. So you have to list down the importance of CD. Third question that I wanted you to practice is what steps can be carried to reduce the air resistance of a moving object. Fourth question, what is the significance of having an aerodynamic design approach? So try to give the answer for this question from your point of view as well after you have understood today's lecture. So fifth question, very simple question, what is downforce and its role in aerodynamics?
So here I have listed the references from where this PPT has been prepared. So you can see I have mentioned 5 references for you to go through whenever you find any difficulty in any of the slides. So these are the reference lecture notes for that purpose.
So thank you. Hope you would have understood today's lecture, and we will cover the remaining in the next lecture.